Now, to do discussion of the refrigeration cycle. Okay. Now, as you know that what is refrigeration and what is heat pump. Okay, means what is refrigerator and what is heat pump from your second or thermodynamics chapter. I think all of you have some idea about refrigerator and heat pump. Okay. Now, uh, what is first of all refrigeration cycle? When you discuss that, for the first question will be in your mind that what is refrigeration or what is refrigerator, right? Now, refrigeration is something where the main is thing that the cooling of a system, where the cooling of a system is obtained below the temperature of its surrounding. So below of its surrounding temperatures, where the cooling of the system, of a cooling of a system, that is basically refrigeration. Okay, and as you know that heating in cycle, and this is a Carnot heating in cycle. For as like for heating in cycle, one is high temperature reservoir, one is low temperature reservoir. In between, heating in cycle operates from high temperature reservoir to low temperature reservoir. The heat is transformed from high temperature reservoir to low temperature reservoir. But when you discuss that heat pump and refrigerator from the previous knowledge of your second thermodynamics, we can apply here that it's basically refrigeration cycle operates on basically in reverse heating in cycle, and it is also sometimes also called reverse Carnot cycle. Okay, now as you see that this is a high temperature reservoir. Okay, high temperature reservoir, and this is a low temperature reservoir. So as you know that in heat engine cycle or Carnot heat engine cycle, the heat is basically or heat transfer takes place from the high temperature reservoir to low temperature reservoir. But in case of reverse heat engine cycle or reverse Carnot heat engine cycle, which is basically the main principle for working as uh, for heat pump or for working heat pump and refrigerator. Now here it is the low temperature reservoir. Here low temp from the heat transfer takes place from low temperature reservoir to high temperature reservoir. But the amount of heat absorbed from the low temperature reservoir, that is basically here Q2, and amount of heat ejected to the high temperature reservoir, that is here Q1. So Q1 will be, and as you know that from the second law of thermodynamics, that when the heat is transformed from low temperature reservoir to high temperature reservoir, so obviously there is some external agency required to transform heat from low temperature to high temperature reservoir. So there is a work transfer, there is a work input to require for to this, and there is a work transfer. So this is Q2 and this is W, so Q1 will be Q2 plus W. Okay, now so in reverse heat engine cycle basically operate for receive heat from low temperature reservoir, means absorb heat from the low temperature reservoir, and it transfer into the higher temperature reservoir. So this is the, if this principle works, so that basically the device is called basically heat pump or refrigerator, as you know. And COP, and I think you all of you know some idea on COP. COP is basically coefficient of performance, right? So coefficient of performance is basically net effect divided by the ratio net effect divided by net work done. So net effect means here for heat pump, so how much amount of heat is transferred to the high temperature reservoir, that is your basically net effect. So that's why it is Q1 divided by net work done, that will be Q1 minus, because of W is equal to Q1 minus Q2, that's why it is the Q1 minus Q2 as like COP of heat pump. Similarly for COP of refrigerator, means coefficient of performance of refrigerator is net effect, that is Q2. Why it is Q2? Because refrigerator is basically, this is the first line where it takes place, that indicates that where the cooling of a system. So cooling, it's indicate it requires the cooling of any system below the temperature of the surrounding. So obviously the temperature of surrounding is more compared to the temperature of the system. So obviously these two things should be maintained as in case of refrigerator or refrigeration cycle. So this is the main principle. So this is the place where the temperature should be kept minimum so that the refrigeration is cycle is maintained. Okay, so that's why, so the amount of heat absorbed, because of if you want to heat absorb from the low temperature reservoir, then it is supposed to act as a cooling space. Okay, cool space or cooling of a system. So that's why the amount of heat absorbed, if you so amount of as much amount of heat absorbed from the low temperature reservoir, so that basically your refrigerant effect, so that is your Q2. So that's why the net refrigerant effect is your Q2 divided by net work done, that is equal to Q1 minus Q2. Okay, and one more point. So basically if this refrigeration, so basically refrigeration is basically cycle where the different components are there, we discuss on that. Now as you know that in the refrigeration cycle there are one refrigerant, then now name will be there. So refrigerant basically the working fluid, the working fluid in refrigeration cycle is basically called refrigerant. So working fluid which is basically used in case of refrigeration cycle, that is your refrigerant. Okay, but in refrigerant there are lots of other properties, but there should be there some properties so that we can use as a refrigerant. What should be there we can discuss on the next lecture video. But here is the refrigerant is basically the working fluid, as much as we know that is basically that refrigerant is a working fluid which is working in the refrigeration cycle. Okay, now so refrigeration cycle is where refrigeration is where the cooling of a system from the below the temperature of its surrounding. So it should be maintained that below the temperature of surrounding on a particular system. That system is basically called, we can say that this is a refrigeration or refrigerator, and this cycle or this system basically operates on reverse Carnot heating in cycle, you can say that. And obviously the heat transfer takes place from the low temperature reservoir to high temperature reservoir. And the main one point that refrigerant basically your working fluid which is working on your refrigeration cycle. Now refrigeration cycle can be two types in terms of depending on the conditions, the refrigerant is absorbed or it is compressed, and so that's on depending on that. Refrigeration cycle is two type. One is vapor compression refrigeration cycle, another is VAR, means vapor absorption refrigeration cycle. So PCR and VR. Okay, now we will discuss on vapor compression refrigeration cycle, means VCR. So as you know that refrigeration cycle are basically two types. One is basically vapor compression refrigeration cycle, another is vapor absorption refrigeration cycle. So obviously there are some difference between PCR and VRs, because that's why the name is suggests vapor compression refrigeration and another is vapor absorption refrigeration cycle. Okay. Now in the vapor compression refrigeration cycle, as the name suggests, the refrigerant, what is refrigerant? The refrigerant which is basically the working fluid of a refrigeration cycle, that is basically refrigerant. Now, what are those refrigerant? The refrigerant may be that ammonia, water, and R11, R12. We can discuss on this later. But basically, the refrigerant are basically compressed. That's why it's basically called vapor compression refrigerant. And when the vapor is basically compressed and there is afterwards they produce a refrigerant effect, that's why the name is vapor compression refrigerant effect. But VAR cycle, where vapor absorption refrigeration cycle, there are not actually there is actually refrigerant is absorbed and heated, so and they produce actually the refrigerant effect. So that's why the name is VAR, vapor absorption refrigeration cycle. Now we discuss on the vapor compression refrigeration cycle. Okay. Now, as you know that refrigeration cycle is basically where the cooling space is required, cooling system is required, the refrigeration cycle is required. Okay. And one more point in between VCR and VR, that in VCR cycle, that obviously the efficiency is very much high compared to the VR cycle. Okay. And the energy which is used to produce the refrigerant effect, that is basically mechanical energy. And obviously as the name and as the component, if you go through the component parts of the PCR cycle, you can see that more noisy parts, more moving parts are there, so that's why noise occurs, okay, in the system. So these are the all for VCR system in the regards of informations. Now VCR cycle. So in VCR cycle, main component is that first one is compressor. which is basically used: compressor, condenser, expansion valve, and evaporator. Okay. Now, as you see that in this diagram, this is a block diagram of refrigeration cycle, in which the diagram 1 to 2 is basically compressor, 2 to 3 is your condenser, 3 to 4 your expansion valve, and 4 to 1 is your evaporator. Now, first you have to know that what is the function of each and individual component of VCR cycle. First of all is compressor. Compressor main function is to increase the pressure, as well as to increase the temperature also, but of air. Okay, so it's a compressor, and condenser is used to condense the vapor and it transform into liquid. Okay, so expansion valve main function is to reduce the pressure from high level to low level. And evaporator main function is that evaporator. And one more important point, expansion valve, is that the control the refrigerant. Okay, the flow of refrigerant is controlled by the actually expansion valve, but main refrigerant effect produced, that is basically evaporator. Now, main function evaporator is that we absorb heat from the system. And to maintain the lower temperature from the surrounding. So this is the main function of evaporator. So as you know, so this is the block diagram. So 1 to 2 is basically first when the refrigerant is compressed. So obviously they will produce, they go to the condenser, then expansion valve, then evaporator. Now, in the VCR cycle, there are two sides are there: low pressure side and high pressure side. Generally, for the evaporator part, we call that as a low pressure side, because they maintain low pressure and compared to the condenser other side. So that is low pressure side, and condenser is your high pressure side. Main four process that occurs actually VCR cycle. That is, first is compression, second one cooling and condensation, third one is expansion, and fourth one is evaporation. So four process are here. So first of all, compression. Okay. Now, compression process takes place when the vapor refrigerant, or when the refrigerant is compressed in the compressor. Okay, and it reach up to a certain higher level of pressure of means higher pressure level of refrigerant, or vapor refrigerant, or superheated vapor refrigerant. Okay, so compression is process such that, and so the cooling and condensation takes place in process 2 to 3, and expansion process in the expansion valve occurs in the expansion valve. Here, expansion valve are basically used as a throttling valve, you can say that, or capillary tube also it is used. And in case of 4 to 1 evaporator main function to absorb heat or to produce refrigerant effect. Now, so these are the four main processes that occurs to produce a particular VCR cycle. Now, as you know, suppose this is your PV diagram, as you indicate that flow chart, that 1 to 2, 2 to 3, 3 to 4, and 4 to 1, that produce a total cycle. Now, if you draw a diagram on PV, TS, and pH plot in this flow diagram. So in PV diagram, suppose this is your initial state. Okay, so this is your, as you know that from the pure substance chapter, so this is the diagram in which the refrigerant is basically in your saturation in state. Okay, in saturated in state. So then refrigerant maybe it's basically dry in conditions, or it may be wet in condition. One indicates this point here, PV diagram in this point. Okay, so 1 point may be here, or 1 dash point may be here. The starting point of, you can say, the VCR cycle. This point indicates the compression, the state of refrigerant is your drying condition. If 1 dash here, that indicates the refrigerant is your in wet condition. So that means there are drying condition means there in refrigerant there is no liquid refrigerant are present. But in case of wet refrigerant, that indicates basically there are vapor as well as some liquid refrigerant also present. So in 1 dash, in 1 only vapor refrigerant are present. That's why it is called dry compression. And in case of 1 dash to 2 dash, it is called basically the wet compression. So first of all, in PV diagram, it indicates the compression process takes place in the piston cylinder assembly. When they take place, what happens, that obviously it takes up to the state 2. If it is starting point is 1, if the starting point is 1 dash, the starting point will be 2 dash. Okay, so that if this compression in this compression basically occurs in reversible adiabatic in manner. So obviously the entropy will be constant. So if the entropy is constant, that's the process is called basically in reversible adiabatically, that is called isentropic process. Now, so process from process 1 to 2 and 1 dash to 2 dash, that indicates basically your compression process. That compression process may be dry compression, maybe wet compression, depending on the condition of your refrigerant. If it is in drying condition, is there is no liquid refrigerant are present, that is called dry refrigerant. Or if the any refrigerant are present, is the liquid refrigerant are present, and then compression process takes place, then it is called wet compression. Okay, but we can say that in between dry compression and wet compression, dry compression far better, because wet compression is very dangerous for the compression process, compressor or piston cylinder assembly, because there are some liquid refrigerant present in case of wet compression process, and that liquid refrigerant or liquid bubble or droplet can affect the cylinder piston assembly. So, and obviously wear also. So they will affect. So that's why we prefer that dry compression takes place in the compression process. Now, 2 to 3. So 2 to 3 basically condenser. So main function to condense. So 1 to here it is basically is your in superheated state, indicates as the superheated vapor, or it may be saturated vapor condition. Okay. Now when they condense means they reject heat to reach when the refrigerant is vapor refrigerant, or it may be reach up to after compression superheated vapor refrigerant. When they reject heat, so from process to 2 they reject heat by the condenser, and when they reject heat and that produce they actually produce the liquid refrigerant. And basically, as you know from the properties of pure substance, this is a saturated liquid line, this is a saturated vapor line. So it reach up to this point, 0.3. So 0.3 after condensation, the main objective is that to transform or to form liquid refrigerant from vapor refrigerant, or it may be superheated vapor refrigerant. But main function is to form liquid refrigerant, okay, or to produce liquid refrigerant. Now, from 3 to 4 is basically expansion valve are there. So expansion means the pressure is reduced in this fashion. So in this expansion valve, or you can say that a capillary or throttling devices, the main function is that pressure is reduced from high pressure to low pressure. And as you know that basically throttling devices, the process is basically in manner in adiabatically, but in irreversible manner. Okay, and it is as it is irreversible in nature, so that's why it is joined by a dotted line, because we know that reversible process are line, but in case of irreversible process are joined by a dotted line. Okay, so 3 to 4 is basically throttling process, and in this process the enthalpy is constant, so that's why it is called so isenthalpic process. So that's why 3 to 4 is point here. Okay, so this one. Now 4 to 1 is process in which the heat is absorbed from the system. Okay, so it is absorbed from this section. So this is the PV diagram of the Pcr cycle. If you draw the TS diagram corresponding this phenomena, you can see that this is a 1 to 2 basically your, this is 1 to 2 basically your compressor processes takes place, compression process takes place. If it is a dry compression, here 1 to 2, and 1 dash to 2 dash indicates your wet compression. Again, it may be 2 to 3, it may be 2 dash to 3, but main function is that they reduce, means they reject heat in the condenser. They reject heat and form or to produce liquid refrigerant at state 3, and this is the state 3, and in between state 3 to state 4, the expansion valve in which they produce actually the isenthalpic process, or you can say that enthalpy is constant, or because there are throttling device or expansion valve are used to reduce the pressure, to reduce the level of pressure. So they reach this point at this irreversible nature, and again 4 to 1, this is the pressure, this is the point where the evaporation process takes place, evaporator takes place, and then actually main function of evaporator, that it is main function is to produce refrigerant effect. So refrigerant effect produced from 4 to 1 state. So as you see that as the level, so P1 is here, that is your pressure level P1. Okay, this is the P1 level. The P1 pressure indicates your condenser pressure. That's why in PV diagram P1 is higher than P2. So P1 greater than P2. That's why it's called high pressure side, and that's why it's called low pressure side. So corresponding this, if you draw the diagram or pH diagram, you can see that This is the phase diagram of corresponding process 1, 2, 3, and 4. In compression process takes place 1 to 2, cooling and condensation takes place 2 to 3, and expansion 3 to 4, and evaporation 4 to 1. So these are the processes that constitute a VCR cycle. Okay. Now in the next lecture video, we will discuss on actually performance and capacity of VCR cycle, and what is 1 tier, 1 ton of refrigeration, what it indicate, and what is refrigerant, and what is VR cycle, and what are the components of VR, and what are the difference between VCI and VR. So all those things we will discuss in the next lecture video. Okay, thank you very much for listening and watching me.